Hey class, it's me, Professor Rourke again. So I had another question, which is great from section 8.1 of our statistics class, which is all about sampling distributions and is our first sort of look into the difference between talking about a normal curve for populations versus trying to talk about a normal curve for a sample. Okay, so they're very similar, but also different in the way that we have to find the standard deviation, which is what can throw people off. So let's take a look. Be sure to check also the completed notes for 8.1. So a simple random sample of size n equals 48 is obtained from a population with a mean of 65 and a standard deviation of 16. Okay, so they're giving us a lot of information here. They tell us, first of all, that there's a sample of size 48, okay? And then we don't really know what these numbers mean, but it says the mean for them is 65, and the standard deviation for the population is 16, okay? So that's for the whole population, but we are specifically talking about a sample of size 48, which is different. Okay, very similar, but whenever we talk about a sampling distribution, the mean is, instead of the mean for the population, we still write mu, which is like the Greek letter for m, and then there's a subscript with an x bar. Okay, so they're talking about the mean for the sampling distribution is 65, but if we wanted the standard deviation, like we always they always have the standard deviation in the middle, the mean in the middle, 3 standard deviations to the right and 3 standard deviations to the left. But the problem is the sample doesn't act the same way as the population. We need to take the population standard deviation and then divide by the square root of n. Okay, so for this case, we'll take 16 divided by the square root of 48 would give us our standard deviation for the sampling distribution. Okay, so the key word there is this is from a sample, and they give you the mean and the standard deviation. Okay, so just from that first sentence alone, that was a lot of information, right? But that is all of what we need to start doing in the second half of class. Is they give us a few keywords, and from there, we kind of have to make a lot of recall a lot of information. Okay, so they tell us it's the sample, they give us the sample size, and then they tell us it's the mean and the standard deviation. So from all of that, we need to be like, oh, okay, so they're talking about sampling distributions. And not only that, but we can find out what the mean of the sampling distribution is, and we can find out what the standard deviation of the sampling distribution is. Okay, because if you remember the video that's inside of Canvas and that I've talked about in class, even if the original population is not normally distributed, okay, so it's not a nice normal curve, maybe it's not an SAT scores, it's not height, something all over the place. If you take a large enough sample, the sampling distribution, so if you take a sample, find the mean of the values of that sample, and do that over and over and over again, then that is normal. So that is just something that we need to kind of keep in the back of our minds. Oh, okay, so part A says, what must be true regarding the distribution of the population in order to use the normal model to compute probabilities involving the sample mean? So that question gets to like the heart of the whole reason we're doing this is we want to say it's normal so that we can do what we did in chapter 7, right? Where we can find the probability of something happening, or if we're given the probability of something happening, we can find the actual value, things like that, right? But this is specifically for samples. Everything in chapter 7 was the population. So now we're talking about for samples. So let's take a look. What must be true regarding the distribution of the population? So there's 2 choices. A says there's more than 2 choices. A says the population must be normally distributed and the sample size must be large. Maybe, let's see. B, since the sample size is large enough, the population distribution does not need to be normal. Maybe. C, the population must be normally distributed. Maybe, or the sampling distribution must be assumed to be normal. So these are like, those lovely SAT style questions. First of all, it's nice if the population is already normally distributed, but it doesn't have to be, as long as the sample size is big enough, which needs to be, our textbook says 30. Okay. So for A, the population must be normally distributed and the sample size must be large. No, because it doesn't have to be normal as long as the sample size is large. It's either or. Okay. B, the sample size is large enough. The population distribution does not need to be normal. I feel pretty good about that. C, the population must be normally distributed. Also, no, if we have a large enough sample size. Now, D is the one that I feel like is close to being true. The sampling distribution must assumed to be normal. Well, we don't really assume it unless either the original is normal or the sample size is big enough. So I feel like D is trying to get you. But really, we can't really just like assume it. We have to sort of make sure A, the sample size is bigger than 30, or B, they say the population is normally distributed. So for this problem, it doesn't say anything about it, the population being normally distributed. So we have to check the sample size, which is 48, which is good enough. Okay. So then it says, assuming the normal model can be used, describe the sampling distribution of X. So this is what I sort of did a brain dump on when I first opened this problem up, where I said, okay, since the mean of the population is 65, that means the mean of the sampling distribution is also 65. The only thing that changes is the standard deviation of the sampling distribution. We have to remember to divide by the square root of n. Okay, so A, approximately normal, the mean and standard deviation are the same. No. B, approximately normal with the mean is 65 and the standard deviation is 48 divided by the square root of 16. Close, but backwards. C is approximately normal with the mean is 65 and the standard deviation of the sampling distribution is 16 over the square root of 48. I think that's the winner here. So that looks good. Now, all of that comes down to this next problem where it asks you to actually now take that information, what we have here, and use it to find the probability. Okay, so it says, assuming the normal probability model can be used, which the sample size is 48, so we're good, determine the probability that the mean of the sampling distribution is less than 68.3. Okay, so we're going to do this the same way we've been doing them from chapter 7. It's just the only difference is that instead of using the population mean, and population standard deviation, we use the mean, and we have to use the standard deviation for the sample. Okay, so I hope this sort of makes sense, the general idea. So if you were having some issues with these, it's probably, if I had to guess, just because you're using the standard deviation 16 instead of what we need to use, which is 16 divided by the square root of 48. So when we solved some of the problems in the notes, like 16 divided by the square root of 48 was what the sampling distribution standard deviation came out to be a nice number. Because the sample size was 36. So the square root of 36 was 6, and that's a whole number. And then we just divided, I think it was like 18 by 6 or something. Here, unfortunately, that's not what we have, because we're dividing 16 by the square root of 48, which is not the best, but it's okay. So let's say let's get an approximation using our calculator. 16 divided by the square root of 48. This is what I'm going to enter in for the standard deviation of the sampling distribution, 2.3094, because that's what 16 divided by the square root of 48 is. Okay, so now I'm going to go back to, I'll start with Statcrunch first, and then we'll talk about how you can also use your graphing calculator to do this. So we will go just like before, stats, calculators, normal, right? And then instead of the mean, of 0, that would be good for a z-score. We have 65. The standard deviation, not 16. We're going to put in 2.30940, because again, 16 is the standard deviation for the whole population, but that's not what this problem is asking about. It's asking about just for the samples of size 48. Okay, so what this normal curve is supposed to represent now is not the population, but it's like, okay, if I took a bunch of samples of size 48, what would their averages look like? Okay, so I know that's kind of a crazy idea to think about. But that is what we're basing our samples off of. And this is how we're going to start performing some inferences. So I have that, and then I have that I'm looking for X to be less than 68.3. Okay, so just like for the Chapter 7, they're giving me like the sample mean, they're giving me the X value. So I can enter that in. It says P is less than or equal to 68.3, and it tells me that the area under the curve is what is that? 0.9235. So we're talking like there's a 92.35% chance that the sample mean would be less than 68.3. And now this next question wants us to say greater than 66.2. So again, because it's like talking about the X bar, it's not talking about the population, it's talking about the sample. I want to change this to greater than or equal to 66.2. And then I click compute on Statcrunch, and it tells me it's 0.3017. Okay, so again, I think if there was any particular issues, it probably was, if I had to guess, just from maybe not entering in the standard deviation as the 16 divided by the square root of 48, just maybe typing in, keeping it as 16. So I hope this was helpful. Again, we're going to keep practicing this, but please let me know whatever questions you have. It still would be a good idea to keep practicing these, even though we have some more time before the assignments are due. Okay, thank you so much, class. Keep me posted on whatever questions you have. Oh, I'm sorry, I almost forgot. I also wanted to solve this in the graphing calculator, like I said I was going to. So sorry. So for the graphing calculator, we're going to do this the same way we did in chapter 7, where we're going to hit second varse, which takes us to distribution, and we're still going to use normal CDF. Okay, so first we enter the lower bound. So for the first question, we're talking about less than 68.3. So I'm just going to leave the lower bound as what it has in here. It always automatically reverts when I have it in my calculator to -1,000,099 zeros. You can also just type in -1,000,000. Usually like -10,000 should be enough. Okay, the upper bound for part B, the first one that we did, was 68.3. The mean, again, was 65. And then this is where we have to enter in the standard deviation, which is 16 divided by the square root of 48. So one thing that is, sometimes the graphing calculator is a little bit more steps, but honestly for this one, it's kind of nice because we can leave this as literally 16 divided by the square root of 48. We don't have to actually simplify that. And the calculator can take care of that for us, versus when we did this in Statcrunch, we did have to type 2.3094 in for the standard deviation. Okay, so then that gets me the same answer, which was the area to the left, which is 0.9235. So, and then same thing for part C, where the only difference is greater than or equal to. So instead of the lower bound being a really small negative number, it's going to start at 66.2, and then I'm going to put in a really big upper number. Okay, so I'm just going to put 1 and just a bunch of zeros. The mean and the standard deviation stay the same, and then we can just push enter, and that would get me my area to the right, probably to the right. Okay, so I almost forgot to talk about the graphing calculator steps, but I hope this is helpful. Please keep me posted. Have a good day. Bye.